Welcome to Study Loop.
Welcome to problem number 23.80. This is chapter 23, electric potential. So we are given that there is a sphere having charge q, and we can measure the charge on this sphere by using a technique. The technique is throwing a known charge which is having some charge q. So this here we are given that this charge is equal to 5 into 10 to the minus 8 coulomb. So we do throw this charge from very far away, the very far away, because we have initial potential energy equals to zero due to the electric force, so there is no potential energy in the beginning. So we throw this q charge with some velocity v naught initially, so this is vi, and this particle has velocity v naught at the beginning, so the velocity on this position start decreasing because we have repulsive force due to this capital q on this q. So we have this electric force in opposite direction to the moving velocity of the small q. So definitely the particle will experience this force and the particle will decelerate. And when particle will decelerate, the velocity will keep decreasing. And that's why we have this equation v square equals to 400 meter per second square minus 15.75 over x meter cube per second square. So this is dependence of v square, which is the velocity square of this particle over the distance, and this x is the distance between those two. And this is a linear graph. So first we have to find out the equation using our physics understanding. So we have used this formula here, which is kinetic energy plus potential energy initially. So this formula is conservation of energy. Whatever the kinetic energy it has here and potential energy it has here, it should be the same due to conservation of energy at this point. So let's say we have k final is equals to kf at some point, kf, and at some point we have uf. We know the potential energy between two charges, which is equals to 1 by 4 pi epsilon naught q1 q2 over r, where r is the distance between q1 and q2 charges, and kinetic energy is equals to half mv square. Initially, k is equals to ki is equals to half mvi square. Vi is just v naught, so this becomes half v naught square. At some point we have potential, let's say we have v at some point, and we can assume that this is a final situation for the moment. So my kinetic energy kf becomes half mvf square, which is equals to half mv square. Your initial potential energy ui is equals to 0, since the distance is very large between them. So as r tends to infinity, u goes to 0. So therefore ui initially there is no potential energy between those q and small q. Now finally, let's say the particle has reached x distance, which corresponds to this velocity here. So uf is equals to 1 by 4 pi epsilon naught capital Q small q over x, which is this r. Now putting this all this first, let's say this is first and this is second and this is the third, we have to put this 1 second third in this equation and then compare with this equation. So let's put it. So we have ki plus ui equals to kf plus uf. Ui is 0, so we have half mv naught square plus equals to plus of half mv square plus 1 by 4 pi epsilon naught q q over x. Now looking at this equation, we can simplify this equation. So this becomes v naught square, taking these terms away and taking this term to the left hand side. So this becomes v naught square minus 2k, or k is equals to 1 by 4 pi epsilon naught q q over m times 1 by x, or equals to v square equals to v naught square minus 2q q 4 pi epsilon naught m times 1 by x. All right, now compare this equation with this equation. So we have v naught equals to under root of 400 meter per second square. So this equals to 20 meter per second. So that's your initial velocity. Look at it again. So we have 400 meter square per second square. This is, should be equals to v naught square. Now coming back to the part A, what is the reason behind that the relation between v square and 1 by x is linear? The reason is the conservation of energy. The conservation of energy gives us this equation, and this equation, when we plot this equation with v square with versus 1 over x, this gives us a linear equation. So linear equation is simply y equals to mx plus c, where m is our slope and c is our intercept. So here in this formula we have y equals to v square, and c is your v naught square, m is your this variable, and x is your actual 1 over x. Or you can say that this is capital Y and this is capital X. So let me write it again so that you don't confuse between x and capital X. So your slope is this factor. Let me write it here. So slope is equals to minus 2q capital Q over 4 pi epsilon naught m. We know the value of the mass, we know the value of the q, and we know the value of the slope here, which is this value. We can find out the value of the capital Q. So this is the technique which we have used here to find out the value of the capital Q. All right, so let's find out the value of the capital Q. So we have slope equals to minus 2qq over 4 pi epsilon naught. M is equals to minus 15.75, which is equals to this value. And this has units equals to meter cube over second square. So this gives us q equals to minus minus goes away. So we have 4 pi epsilon naught times m times 15.75 over 2q. Now putting the value of the q here and m here, and 1 by 4 pi epsilon naught is equals to 9 10 to the 9. So q comes out to be 7.01 into 10 to the minus 6 coulomb. This is a positive value. That means it should be positive value because we had this small q as a positive and the particles start moving there. So for the velocity to decrease and follow this relation, there must be some repulsive forces, and that could be only possible that both q and capital Q has same sign of charges. All right, now we have find out the capital Q here value. So this is your part C and this is your part B and this is your part A. Now let's find out the value of the X. So we have Question as follows: how close does the particle get to the sphere? Which means that the particle approaches zero velocity. So your final velocity, which is v, becomes 0. So your vf should be 0, which will give the closest approach, and which will give the x minimum between q and q, and we have to find out this value. So let's go to the equation again. So this is our equation, or this is our equation. So this is 0. So we have v square equals to 400 meter square per second square minus 15.75 meter cube over second square over x. So v is equals to 0. So this, that's v square equals to 0. So this term is equals to 0. So this becomes 400 equals 15.75 over x. So your x is 3.94 into 10 raised to power minus 2 meter, or x equals to 3.94 centimeter. So that's your answer for the closest approach, which means that the distance between q and capital Q, the smallest distance is 3.94 centimeter. All right, so this was part D, and we have solved all the parts of this question. So you can take a look at it again. So this is our first slide, this is our second slide, this is our third slide, and this is our fourth slide. Thank you for watching the video.